Hello, everybody. Welcome to tonight's stream. Let me just post on the dashboard that we are doing a stream here. Content live. There we go. Share this. Okay. And nope, that was the wrong one. Should be episode 2 should be live right now. Edit episode 2. There we go. Okay. Okay. So what we're going to do today is work on just digging a little bit deeper into pygame, which is the it's not a framework. Let's just bring it up. Well, we'll start looking at it. It's not a framework per se. I would say pygame is some libraries. So if we look about pygame, it's a set of Python modules, which is kind of Python's another way of kind of saying libraries or files. Source code designed for writing video games. It adds functionality on top of the excellent SDL library. This allows you to create fully featured games and multimedia programs in the Python language. So the SDL library, cross-platform design a low-level access to audio, keyboard, mouse, joystick graphics. Okay, so it's not a framework. It's kind of a build your own framework thing, which is really what I was looking for. I'm not doing this to utilize like Unity or Unreal or Godot or Love 3D or any of the kind of off-the-shelf game engines. I want to increase my programming skill set and figure out the physics and the collision detection and all of that stuff by practicing the best practices that I can find on the web and utilizing the documentation and just using it kind of as like a hobby and practice. Not planning on quitting my day job and becoming an indie game developer as of now, but I do like using Python. I think that Python is a really cool language. I think that it has a lot of really cool benefits. And then along with any other language, there's its positives and its negatives. Python, of course, is a dynamically typed language, so you do lose some type safety. But along with that, you have the expressibility and the ability to more rapidly prototype what you're looking to do, because you don't have to have a lot of boilerplate code. You don't have to have a lot of like compile time checking and things like that. But you just have to be more careful in the way you create stuff. So this is STL, and I think STL you can use. It's written in C, works native C++, and there are bindings available for other languages, including C# and Python. I didn't know there was a binding for Python. Or I mean, I knew there was a binding for Python. It's pygame. Rust, TypeScript has one. Lua, OCaml. Oh, I didn't realize you can do it in OCaml. C#. I was only aware of monogame, but I digress. Let's get on to make sure that we're doing the pygame stuff. So if we look at pygame and we hit getting started, you install it through pip, which is the Python package manager. User flag to tell you to install in a home directory rather than globally. See if this works. Run one of the. So as I'm going through the documentation and kind of doing this stuff, you will see that I'll probably move pretty fast, and that's just I've been doing this for a while, so this isn't a tutorial where it's for beginners. It's kind of like you watching me kind of figure stuff out and seeing how a software engineer might solve problems or look and do their research and things like that. Because I'm starting from knowing essentially nothing about Pygame, just that you can make some cool games with it, and knowing nothing about art, and kind of looking up the tutorials as I need, and just working through. The goal, I say, is just to get this kind of now it doesn't even have to look even more complicated than this, just to get like a demo of the ability to throw a ball and have the pup run and or walk at this stage, walk and go pick up the ball. So that's where we are with that. Let's jump right in. Okay, so here's the docs. So welcome to Pygame. Once you've got it installed, pip install Pygame or pip3 install Pygame. All right, let's do that. I have PyCharm on the computer. I have PyCharm on the computer, so I guess we'll use PyCharm. We could also use VS Code. I haven't really used VS Code a lot for Python development. I like PyCharm. PyCharm does a good job of let me do a new project here. Let's location. Let's do it under YouTube. Dog game. And we'll have a virtual environment. Python 3.9 is good. Not empty. New virtual environment. Environment location directory is not empty. Oh, I didn't know you couldn't do that. Does it have to be? Do you have to have an empty directory? Let's do a new folder then. src. No, let's do Python. And then that works, I guess. Create it. This window. We'll just overwrite this one. And oh, you guys can't see. Can I move this? Oh, that's not what I want to do. This guy. Let's put him like right there. I wonder what that looks like. Let me see what that looks like. Yeah, in any case, we'll figure it out. Name, main, print, high, PyCharm. We're gonna get rid of all this. I don't really even use that stuff very much. So let's do Python console. Allow pip3 install Pygame. Right? Invalid syntax because I spelled it wrong. Pip3 install Pygame. Invalid. Is it pip3 dash install? Ah. Pip3 install Pygame. Just add it from here. Pygame. There it is. Install package. It's installed. Okay. Cool. Now we've installed. Welcome. Here's a good example of basic setup. Opens the window, updates the screen, handles events. Documentation, readme, basic information. For a nice introduction to Pygame. Pygame is highly portable, runs on nearly every platform. Let's see what Bing has to say about us. No, I thought you could get Bing to just I thought it would right here? Is this where it does? I have Copilot Pre right here. Dual CPUs, works with many operating systems, truly portable, it's simple, sweet. So it's recommended to do this line-by-line chimp tutorial, which I actually looked at earlier today while at work. And we go to my notebooks here, inbox. There's the chimp tutorial right here. Okay. So this is 2.6. So in the pygame examples, there's a simple game chimp. This example, in the pygame examples, there's a simple game named chimp. To program an image, run it by running Python m pygame examples.chimp in your terminal. Pygame examples.chimp in your terminal. Code blocks. When the code is also been mentioned how the code could be improved while error checking could help out. It's an excellent tutorial. Okay. Can I see this code then? External libraries. Python. Lib. Pygame. Examples. Chimp. Alright, let's take a look at chimp here. So this is the code that he's talking about here. What modules are we importing? Warning, fonts disabled. Okay. This simple material sample code. Okay. So here it is again. Let's actually look at it. Is this it? No, it's chimp. No, that's chimp. Chimp tutorial. There we go. Okay, so this is it in code there. So let's do it side by side so I can be looking at it while also looking at the code over here. So we'll close this down. Can you guys see that okay? Maybe I'll increase the font size. How do I do that? Font size. Increase font size. Okay. Increase it again. Increase font size. There we go. So now it should be easy to see. Okay, the simple example named chimp example simulates a punchable monkey moving around the screen. Oh, that's cool. First look at the pygame. Once pygame is fully installed, you can find and run the chimp for yourself in examples. Pummel the chimp and win money. This is the code that imports all the needed modules. It also checks for the availability of some of the optional pygame modules. So that's right here. And then it checks if the modules are not there. Prints a warning. Goes into the directory. Or your data directory and your main directory. Oh, that's interesting. Functions to create other resources. Optional data value false. Loading. Here are two functions we can use to load images and sounds. Each functions individually. Define load image. Named function, scale 1. We have some default argument values, full name, OS path joid, data directory name, image convert, size, okay. Transform it, if color key is not none. So this is a function to load an image. Cool, okay. Then a function to load sound. I feel like this could be a library function. This would be something that would be of a benefit of having as a library function. String is a function that does check to see if it's ranking correctly. If not, returns a small class that has a dummy play method. Very interesting. Okay, so then it won't fail if you don't have it. Game object classes. Fist. Moves a clenched fist on the screen. Dunder and knit. sprite init, call sprite initializer, self image, self rect, load image first. This ping, self.fist offset, self.punching equals false, define update. So the update method is what changes the state of the fist. Okay. The punch. Hitbox. Okay. Return collided. If not, self.punching. If not punching, which is false, self-punching equals true. Hitbox is self.rectangle.inflate. I don't know what that is. That's okay. All sprites have an update method. Okay, this function is typically called once per frame. It is where you should put code that moves and updates the variables for the sprite. The update method for the fist moves the fist to the location of the mouse pointer. So this is so this fist inherits from sprite, which is a class in pygame, and all sprites have an update method. So this is an override of the update method. It's where you put code that moves and updates the variables for the sprite. The update method if the fist moves the fist location of the mouse pointer. It also offsets the fist position slightly if the fist is in the punching state. So my question now is, does update, so with Python, a lot of object-oriented languages come from the Java family, like Java, C#, I think even maybe PHP, but don't quote me on that. Those languages have encapsulation and inheritance and polymorphism, the three tenets of object-oriented programming. When he says that all sprites have an update method, that means that it is defined in sprite that you need to have an update method. We call that a contract. C# and Java implement those through interfaces. So my question, if we go back to the documentation here, is there a reference? So we see sprite, right there. Okay. Is there a reference to update? Alive, yeah. Search for it. Update. Well, it's not update. Wow. Dude, not update. Method to control sprite behavior. There it is. Okay. Update takes in args and quarks. The default implementation does nothing. Okay. So it's like what we would call an abstract class in C#, where you have to, you're going to implement it, or even an interface, I suppose. You're going to implement it, but the class that, the parent class doesn't necessarily have an implementation. So the default implementation of this method does nothing. It's just a convenient hook that you can override. This method is called by group.update with whatever arguments you give it. There is no need to use this method if not using convenience method by the same name in the group class. Search examples. Okay. So let's go back there. That makes sense. So this is the override or the implementation of update for this fist. So this fist is saying, give me the mouse. It looks like pygame.mouse, get position, and put the top left of a rec must be a rectangle, top left to that position. Self rec move IP. This IP. Oh, okay. So it doesn't talk about that. Boom, 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 boom. Move IP. Self rec dot move IP. Self fist offset. So that's an offset, means that when we load the image on this screen up here, we're moving it over to, like, this must be the offset. So this screen must be some amount of size. Where is the screen size? Interesting. I don't see the screen size. Define load, fist, temp. Is there a game? Oh, there's a main. Okay, so the screen is 1280 by 480. So I'm thinking if we are offsetting this fist by negative 235 and 80, then we're moving over to the left. And we're moving it up. So where would it really usually be filled then? Okay, maybe they're gonna get into that, but I don't understand how moving it to the, because the way that let's see, do I have white? The way that your coordinate system works with games, I know this much at least, is that you learn in school, you have your like x and y coordinates, and you can have like a function, right, method, this being x and this being y. Well, in game programming, you're kind of rotated 90 degree, what should be 90, essentially 180 degrees rotation. So this is your x over here, and this is your y. So your x increases this way, and your y actually increases in the down direction towards the bottom of the screen. So if we're going to offset, if we're going to offset this guy as it said down here, what does it say? Fist.offset negative 235.80. Wherever they put him, that means they're pushing him that way. So I wonder if he gets put in a center, kind of, he gets like here, this fist, and if we're offsetting at negative 230, maybe it ends, maybe it kind of ends like this. It gets down a little bit farther, like this, and it goes up, because that's going to be a negative direction for the y, and it goes over, because that's going to be a negative direction for the x. We're going to find out. I think that's how most gaming engine stuff works. So I did do, I guess I remember I said I haven't done any game development. That's not entirely true. There were a couple problems when I was doing Racket, using the basic student and intermediate student language on Dr. Racket, where you did build like a little Space Invader game. So I remember them talking explicitly about how the coordinate systems work in the windows for games, and it's separate. It's kind of like I said. So if we're looking at this as a mathematical rotation, if we rotate this whole coordinate system 90 degrees to the left, then we would end up with x going up like that and y going like that, right? So x would be, this would be x, and this would be y. And then if we rotate it again 90 degrees, then we would have our x going this way and our y going this way. Oh, so I guess it's not a rotation. All right. In any case, it's just the way it is. Oh, what transformation would that be then? That would be a reflection. Oh, that would just be a reflection. So it's just reflected about the. Yeah, it's just, so if we called this the x-axis, then this is just a reflection about x. Okay. All right. That's, like I said, that doesn't make any that doesn't matter for this. So let's continue on to the next parts. So we update it, punch him. If he's not punching, then we do a self-punching. Hitbox self.rectangle.inflate. Oh, we have a target. We pass in the target if the fist collides with the target. Hitbox is self rectangle inflate. -5, 5. I want to see what this inflate is for. So self is a sprite. So we need to go back to the sprite class and look for inflate. Inflate? Rect. Self. Not rect. So is that a surface? So is this a new object? Sprite for each. So it's surfaced. Surface is where it gets that rectangle from. So back to sprite. Surface. Surface. And then rect. So this is essentially just how you use documentation. Rect. Dot rect. No rect. Oh my god. Dot rect. No. No. Oh. No, it's a surface, so I want inflate. Inflate's not there? Let me search here. Pygame rect inflate. Oh, so it's rect? But I thought rect was... I thought it returns a surface. Whatever. Inflate. I'm gonna go through that here. Grow or shrink the rectangle size. Oh no, that's really cool. Returns a new rectangle with the size changed by the given offset. The rectangle remains centered around its current center. Negative values will shrink the rectangle. Note, use integers. If the offset given is too small, center will be off. Negative values will shrink the rectangle. So is this a shrinking of the rectangle? Yeah. So we're shrinking the rectangle. So the hitbox... So the fist... The hitbox around the fist is... shrunk 5. I wonder if that's because it's being animated from the game standpoint. So it's being like utilized. I don't know. Okay, but I want to go back self.rect. So sprite.rect. Let's go back to sprite. I want to, for sure, one of the kind of the tenets of programming well is trying your best of your ability as low as you need to go in the abstraction layer to understand what is happening. Not far too often people go to Stack Overflow and they cut and paste something and kind of just blindly go with it, and then when later on you need to refactor that or change it, the maintainability becomes hard because you don't really understand in the first place what the code was doing. Which, again, that doesn't always, you don't necessarily 100% of the time need to understand what the code is doing, but you need to understand what it is doing up to the abstraction layer where you have, where it's concerning for you, where you need to, essentially. So I don't need to know how in C# or someplace a sorted method is internally implemented, if it's using quick sort or bubble sort or any of the other various sorting algorithms, but I need to know probably what the big O of its implementation is, and how to use it, how it is called, and what the syntax is in the particular language I'm using. I hope that makes sense. If you want me to do a video on what I'm talking about, kind of like general software engineering problem solving, leave a comment below. So back to the attributes. So this is sprite. So I gotta look at, so another way, I think another way you can do this is you can go to here and I could say import pygame as PG, just like they did. It's there. And then I could say help pg.sprite. Nope, module has no attribute sprite. Is it? Oh, it's small sprite. Right, and it should give me, there we go. Now, if I go up to the top, I'm hoping I'll be able to see all the attributes. Classes, there's classes. Class. Dirty sprite. Maybe not. Group single. Functions, no. Huh. So where is the rect? Because we're saying self.rect. So that's saying rect is part of sprite. Oh. Look at here. Self.rect is set to load image. So we actually need to look at the function load image. Watch that return rect. Guarantee. Load image. I think it's PG load image. Is it just? Yeah, it's just load image. So I bet it's coming directly from pygame. Let's see. Load image. What? This doesn't make any sense now. Load underscore image. Where's that coming from? Init function. Oh. It's getting late. Load image was defined up here, remember? Load image was defined up here. So load image is image.load. So pygame image. Oh my god. We're gonna get this. Don't you worry. Pygame image load. Where's load? Load basic, load extended. It's just called load. Is there a from bytes, from string, 2 bytes? Load, there we go. Loads a new image and gives us a surface. And the surface gives us surface.rect returns a rectangle, and the rectangle does the subsequent inflate. Okay. Now Where's the game? There we go. Punch. We punch. Not punching, punch. Here we create a class to represent the player's fist. It is derived from sprite class included in the pygame sprite module. That's created for a single dude. Be sure to call the init function for a base class is null sprites. We use this game uses one of two sprite drawings. Sprites have one of the sprite drawing group classes. These classes can draw sprites that have an image and rect by simply changing these two attributes to render. We draw the current image to the current position. All sprites have an update method. This function is typically called once per frame. It is where you should put code that moves and updates the variables for the sprite. The update method for the fist moves the fist to the location of the mouse pointer. It also offsets the fist position slightly if the fist is in the punching state. The following two functions, punch and up punch, change the punching state for the fist. Punch, if not self-stop punching. Unpunch, called to pull the fist back. Self-stop punching equals false. Change the punching state. Okay, and then we have the chimp. Let's see if so we have a chimp. We can spin the monkey when it's punched. Okay. Screen. Does this one have a screen too? No, why does this one have a screen? Walk or spin, depending on the monkey. Okay, so this is a state machine. So this monkey has a walk or spin. While okay, walk is move the monkey across the screen and turn at the ends. And this is private, so in Python, underscore are ways to set attributes to private or method calls in this sense. Move the monkey across the screen and turn at the ends. New position, move, self.move, 0. If not, self.area contains new position. If self.rect left is less than self. Right, don't move. Self.image equals pg.transform, not flip. And spins the monkey. Okay. The chimp class is doing a little more work than the fist, but nothing more complex. This class get back and forth. When the monkey is punched, he will spin around. Too exciting effect. This class is derived from the base. Initialized the same as fist. While initializing, class also sets the attribute area to be the size of the display screen. The update function for the chimp simply looks at the current dizzy state, which is true when the monkey is spinning from a punch. It calls either the spin or walk method. These functions are prefixed with an underscore. This is just a standard Python idiom, which suggests these methods should only be used by the chimp class. We could go so far as to give them a double underscore, which would tell Python to really try to make them private, but we don't need such protection. Position. Initialize everything. Before we do much, we need to make sure it's modules. In this case, we also open a simple graphics window. Now we are in the main function of the program, which actually runs everything. So down here, the main initialize everything it needs, then runs in a loop until the function returns. pg init screen pg.display set mode 1280. PG scaled. Screen 1280 by 480, so it's 1280 wide by 480. Set caption monkey fever. Mouse set visible false, so we're not gonna see the mouse. Initialize pygame takes a bit of work for us. It checks through the imported modules and attempts to initialize each one of them. So up here we did that with the imports. Okay. And the main DIRs. Okay. So then down here, background, text. Next we set up display graphics mode. Used to control display. In this case we're asking for a 1280 by 8480 window with the scaled display flag that's automatically set up to windows. It is much larger than the window. Last we set the window tile cursor for a window. Very basic to do, and now we have a small black window ready to do our bidding. Usually the cursor defaults to visible, so there's no need to set the state. Create the background. Okay, so surface. So it keeps on mentioning surface a lot. I was watching a video by Clearcode. I've been watching some pygame tutorials, but I haven't programmed it yet. He talks about surface. Put text on the background, display the background, prepare the game. Here we create all the objects the game is going to need. Whiff sound, load sound, punch sound, load sound, chimp equals chimp, fist equals fist. All sprites equals PG sprite render plane. What is that? We actually use a special sprite group named render plane. This sprite group can draw all the sprites it contains to the screen. It is called render plane because there are actually more advanced render groups, but for our game we just need simple drawing. We create the group named all sprites by passing a list with all the sprites that should belong in the group. We could later on add or remove sprites from this group, but in this game we don't need to. The clock object we create will be used to help control our game's frame rate. We will use it in the main loop of our game to make sure it doesn't run too fast. So when would we use... You know what? I'm going to ask ChatGPT. When would we use... When would we use other render groups or remove sprites from all sprites? There's complexity using other render groups. If your game has multiple layers, background characters, you might want to use different render groups for each layer. Oh yeah, okay. Some render groups might be optimized. Conditional rendering, if you have sprites that only need to be rendered under certain conditions. Okay. Nice. That's right to the point. So I would use them when we were doing different backgrounds, different layers, essentially, in the game. You know how we did the layers when we were drawing the dogs yesterday? Essentially the same kind of thing. The clock object will be used to control games. We use it in the main loop of our game to make sure it doesn't run too fast. should be at 60, right? Yeah, clock tick 60. Nothing much here, just an infinite loop. Going equals true. While going, clock.tick 60. All games run in some sort of loop. The usual order of things is to check on the state of the computer and user input, move and update the state of all the objects, and then draw them to the screen. You'll see that this example is no different. We also make a call to our clock object, which will make sure our game doesn't run faster than 60 frames per second. Handle all input events. This is an extremely simple case of working the event queue. For loop. For events, if the event type is quit, then going equals false. Also, if the event type is key down, and event key equals PG key escape, going equals false. Also, if event type equals mouse button down, if fist.punch chimp punch sound play, chimp punched. So we'll do this a little bit different from an object-oriented standpoint. I know this is written by the developer of pygame. Cool. Appreciate that. Done a lot of cool stuff. But the playing of the chimp sound of punched belongs to the fist. It's the punch or the sound of missing. So we should have a method in the fist that passes in polymorphically some kind of sound, and depending on the state of the fist at the time, it calls that sound. So I would do that with the dog, and when we get to that point, remind me to bring that up, or I'll try to remind myself. Okay, but in any case, all sprites.update, draw everything. All sprites draw, PG display flip, PG quit, game over. Draw the entire screen, screen.blit. The first call, sprite groups have an update, which simply calls the update method for all the sprites. Each of the objects will move around depending on which state they're in. This is where the chimp will move one step side to side or spin a little further if he was recently punched. Draw the entire screen. Now that all the objects are in the right place, time to draw them. Screen, blit, background, 0, 0. Draw the background on the entire screen. This erases everything we saw from the previous frame. Slightly inefficient, but good enough for this game. Next we call the draw method of the sprite container, since this sprite container is really an instance of the render plane sprite group and knows how to draw our sprites. Lastly, we flip the contents of pygame's software double buffer to the screen. This makes everything we've drawn visible all at once. And lastly, we flip the contents of pygame's software double buffer. Background. Here's this frame. Flip. And then draw. So the draw method, since the sprite container is really an instance of the render plane and knows how to draw our sprites. Okay. I'm going to need more explanation of that later. User has quit, time to clean up. pg.quit. Alright, let's try to play this. I want to see what this looks like. I didn't play it. Why didn't it play it? You don't, it doesn't play? Alright, file. There we go. Oh, okay, so, oh. That's kind of cool. Okay, that's what I was wondering. That's pretty cool. It's kind of crazy. Okay. Okay. Nice. That was kind of cool. All right. Yeah, that makes me pretty excited. All right. So utilizing that, I think that the load image is obviously a cool, like these functions that have been written kind of as library functions. I would almost wonder if we can. These are under examples. Let me see something. Can I import pygame dot examples as lib dot load image? Oh, chimp. That would be chimp. Examples.chimp. Let's see. From pygame.examples.chimp import load image and load sound. Do I have to put a thing here? Load sound as nice. No, there's nothing there. It's gonna fail. Okay, cool. I think that I would utilize those then. Why, if something's working well, and it is, and these work really well, I don't need the fifth though, or the chimp, the main. We are gonna borrow some of the code from the main. Okay, so let's go. Let's go back to our console. Copy that. Import pygame as PG. That. We're not gonna use a class right now. I kind of just want to see my dog objects on. What is import os dot get pw get cwd os dot get current working directory. Let's see where we are. Dog python. So then I can import from put text in the background. Why am I not logged into GitHub? Put text display, PG font, background, yeah. So we could do pg.init, start everything. Do screen equals pg.display dot set mode. I don't know. Don't know what to do. Can you do os dot? Let's just do. Let's do 1280 by 720, because that is like a 720p, isn't it? Yeah. And then we'll do pg.scaled. Select it here, pg.display.set caption. puppy walking. Don't need a mouse for right now. Create the background. Say background equals PG surface. Oh, I need a new surface. Yeah, that's an object. Or screen. Not get size. Okay. Oops. Background equals background dot convert, and then background dot fill. Let's see what the colors are. I thought there were a bunch of colors. I thought you could do a name. Name colors. Whoa, look at all these colors. Let's do this. Corn silk. Corn silk. Parameters, no. Color name. Oh, okay. Corn silk. Color, where's... Color. Background dot fill. Self. Color. Do I do color here? pg.color. Color name. Background fill. Pygame color. Color value. Color or string or int. Ah, okay. Color value. Ah, shoot. What was it? Corn silk? Corn silk. Okay. Fill. Within that. Display the background while setup finishes. Green dot bullet. Background 0, 0. This will blit our entire blit player not immediate. Normally the display must be updated. In this case, the flip function works nice because it simply handles the entire window area. Ah, okay. pg.display.flip. And if we load all objects, let's just do going equals through. And just make sure while we have everything going. Clock.tick 60. I didn't create a clock. clock equals pg dot time dot clock. All right, now I created a clock. Forgot Python booleans are capital. Handle events for event in pg.event dot get. It's just gonna do if event type equals pg.quit. And we'll do going equals false. All right, so with that, we should have enough to see the background. There it is. There's our background. Okay. So why didn't it's not exit? How come it didn't quit? Oh, I didn't do PG quit. PG quit. Now it'd be okay. No? Why? Why is that doing that? So, if event type equals going equals false. Oh, that's supposed to be part of this. Okay. That makes sense, yeah. Because this is not ever going to get out of there. Yeah. Come on, Keenan. All right. Whoop. Video system not initialized. I'll go and clock that tick. pg.init. Video system dot. Clock that tick. PG display. PG display dot flip. Do I have to do that in that sense? Why? Where is the error? Line 24. Going equals true. Plot that tick for event. All sprites dot up, draw everything. Blit. Why is it initialized? Set mode, initialize everything. How is it not? pg.init. Screen. radio system not initialized. Where am I missing something here? Must be something easy. I think we need to do a blit. Green dot. Blit. Yeah. Background. It's not saying it's not initialized, so we're gonna blank everything out again. Then we'll do pg.display dot blit. Let's see what this does. No. Display surface quit? What does that mean, display surface quit? Display surface quit. Why? Yeah, why? Piece of code. Oh my God. Yeah, I was calling the function. Oh my God. It's an enumeration. Quit. There we go. Perfect. Okay. I think that's it for tonight. I know I wanted to put the dogs on there, but we got good progress. We got to the point where we have a little background area. We could even draw a little... well, I'm not going to draw any boundaries yet, 'cause I still have to learn how to get that portion to work. But, I mean, we got an empty screen up on the board, and we read, learned, and understood about pygame. I'm going to have to get off for the evening, though, and I will try to be on again tomorrow. I'm Keen and Can Do, and until next time, we'll talk to you later.